Hello everyone, I am Gyan and you are watching the second session of Java and Wave, variables, data types and operators. In this video, we will learn about the typecasting of primitive variables. So what the typecasting means? To temporarily convert the data type of variables and constants, we use typecasting. For example, we can convert the float into character, integer into byte using typecasting. As the name suggests, we cast the variable or constant to a new data type, but temporarily. There are two types of type conversion. First one is called widening and second one is called narrowing. In the widening, we convert the smaller size data type into a bigger size data type. For example, if we convert the character data type into float data type, or we are converting the byte data type into integer data type. So these conversion of data types are called widening. There are two types of widening supported by Java. First one is called implicit widening and second one is called explicit widening. Implicit widening happens automatically by the compiler. Implicit widening is default widening. We already have learned assignment rules of Java. So we know that whenever we store a smaller data type into a bigger data type, then compiler does the widening automatically. If you don't know the various assignment rules in Java, the link is given in the video description below. And second widening is called explicit widening. Explicit widening happens by programmer. But since the compiler also does it automatically, so explicit widening is not required. Although we can do the explicit widening, but it is not required. Compiler does it automatically. Other type conversion is called narrowing. In narrowing, we convert bigger size data type into a smaller size data type. For example, if we convert the integer data into the byte data, if we convert the float data into character data. So these things can happen, and this type of type conversion is called narrowing. Again, there are two types of narrowing. First one is called implicit and second one is called explicit. The implicit narrowing happens automatically by the compiler, but it is very rare. We already have a separate video on implicit narrowing. The link is given in video description below. Implicit narrowing only happens with the integer and character constants, and other narrowing is called explicit. The explicit narrowing is provided by the programmer. For example, if we need to convert a float data type into character data type, then in this case we need explicit narrowing. And the explicit narrowing is always provided by programmer, not by the compiler. Since programmers do not need to care about the implicit narrowing, and explicit narrowing is useless. And since the implicit widening and explicit narrowing are common. So in the common term, the typecasting has two types. First one is called implicit typecasting. We also called it widening. And second one is explicit typecasting. We also called it narrowing. This is the example of implicit typecasting means widening. We are assigning a character literal which has 16-bit storage into the variable of type integer which has 32-bit memory location. So first, the widening has to occur. This 16-bit data has to be converted into the 32-bit data by appending 16 zeros before it, and this 0 becomes the MSB. That's how the 16-bit data becomes wider. 16-bit data becomes the 32-bit data, and this 32-bit data is going to be stored in the 32-bit memory location. When we assign a lower size data to a higher size or same size variable, then the compiler does not generate any error. Implicitly, the compiler typecasts the lower size data into the higher size data. So this typecasting is also called the widening. This type of typecasting automatically done by compiler is called the implicit typecasting. Let us try to run this program. Vi typecasting.java. Here we are storing the character literal a in the integer variable I, and then finally we are printing the integer variable I. Let's save and compile it. Java C typecasting.java. Compiles fine and then run it. Java typecasting. It runs fine and printing 65. In this program we are assigning an integer literal into the byte variable b. In this case, the range of integer literal is greater than the byte variable b. It's out of the range of -128 to 127. That's why we cannot store it in a byte variable b. If you are writing just an integer literal, by default it will be a 32-bit integer. Here we are writing byte b is equal to 2. By default the 2 is 32-bit integer literal. But since the 2 is in the range of -128 to 127, so this 2 can be assigned in the byte variable b. Compiler does here implicit narrowing. Compiler cut down the first 24-bit to store it in the byte variable. But the compiler does it only if the value getting assigned is a literal and it's in the range of the data type at left hand side. And finally we are printing the variable b. We have a separate video on the implicit narrowing. The link is given in the video description below. Let me try to execute these codes. Vi typecasting.java. Right here byte b is equal to 1112 right here, but b is equal to 1112, and then print here b. Let me try to execute it. Compiler says incompatible types, possible lossy conversion from integer to byte. If I write here byte b is equal to 2, then it can be easily assigned in the byte variable. Compile it. Compiles fine and then run it. It runs fine. Since 2 is in the range of the byte. Here we applied the explicit typecasting for the narrowing. If the compiler does not do the implicit narrowing, then the programmer explicitly has to do it. And this is the way of doing explicit narrowing by the programmer. 1112 is a value which is an integer. You want to convert this value in the byte data type. So before the 1112, write here byte in the small bracket. And that's how you will be able to convert the integer 1112 into the byte data type. Let me execute this program, vi typecasting.java, and write here 1112 and typecast it. Write here byte, byte, in between the opening and closing a small bracket. Now compile it. This time compiler will not throw any error. Java C typecasting.java. Compiles fine and then run it Java typecasting. It runs fine and printing 88. Somehow after the typecasting, the 1112 becomes 88. So let's see how the output 88 comes. When we typecast the value 1112, which was actually a 32-bit integer, and we are applying the typecast on it. Because of our typecasting, the most significant 24 bits are ignored by the compiler, and only the least significant 8 bits will be stored in the byte variable b. And this is how we get 88. The decimal equivalent of this byte variable b is 88, and that's how we get the output as 88. We can apply the typecasting on the variables also. If we write here int I is equal to 1112 and then write here I. So again we are typecasting the variable I. Save and compile it. Java C typecasting.java. Compiles fine and then run it. Java typecasting, it runs fine and printing 88. So it's same if you are typecasting the literal or a variable. When we assign a higher size data to a lower size variable, then the compiler generates an error. We have to explicitly change its data type. Like here, we have changed the data type of 1112 explicitly in the byte. Here we are changing the double literal into the integer data type. This type of typecasting is also called the narrowing because we are narrowing the data. Here we are typecasting the double literal 123.4567 into the integer type. Let's see what's happening here. We have the integer variable I, which is 32-bit, and we have to store the 123.4567, which is a double literal. If you are doing the typecasting, then first you need to cut whatever is at right hand side of the decimal point or fractional point. So here we have to truncate the 0.4567, and that's how it becomes 123 only. And that 123 is going to be stored in the variable I. Now suppose that we have to store the 123.4567 in the byte variable b. Byte variable is of only 8-bit. Again we will truncate whatever is after the decimal point or fractional point, and then we will store the 123 in the byte variable b. And this is how the explicit typecasting, the narrowing, occurs. We need to convert the double literal 1112.4567 in the byte variable b. We have the byte variable b, which is 8-bit, and we have to store the 1112.4567 into the byte variable b. So first we need to truncate whatever is after the decimal point or fractional point. Now we have 1112 remaining, and that 1112 we need to store in the byte variable b. We know that the 1112 is not in the range of byte. Compiler will treat 1112 as 32-bit literal, which is going to be stored in a byte variable, and it will cut the most significant 24-bit and store the least significant 8-bit in the byte variable, as we just seen. So compiler will store the value 88 in the byte variable b. Let me try this program practically. Write here double. Write here 1112.4567. Now compile it. Java C typecasting.java. Now run it. Java typecasting. It's printing 88. That means first 0.4567 has been truncated. then the least significant 8 bit of integer 1112 is going to be stored in the byte variable b. We know that same quantity stored in the float and double are not equal. We already had a video on this topic. If you don't know about this concept, the link is given in the video description below. So the same quantity in float and double cannot be equal. But we can typecast it. If we typecast a double to make it float, then they becomes equal. But if you typecast to float to make it double, it will again not equal. In this case, it results true because we are typecasting the double variable d. Let's compile and execute these programs. Vi typecasting.java, and here we have the float variable f and double variable d. Both are storing the value 1.2, but they are not quantitatively equal. Let me compile and execute it. Java C typecasting.java. It executes fine and then run it. Java typecasting. It runs fine and printing false because f and d are not equal. Now let's typecast the double variable d. Right here, float. Compile and execute it. Java C typecasting.java. Compiles fine and then run it. It's printing true. So if we typecast the double variable into the float, then f and d becomes quantitatively same. But if we typecast the float in double, then the scenario is not the same. It will result false, not true. Let me typecast the float into the double. Right here double. Save and execute it. Java C typecasting.java. Compiles fine and then run it. Java typecasting. It runs fine and printing false. Explicit widening is useless. Suppose that we are storing the character literal in the float variable f. Does not matter, we are typecasting it explicitly by writing float in between the opening and closing a small bracket, or we are not doing it at all. Compiler does the widening by itself. Explicit widening is useless. These two lines have same effect. If we do explicit widening, then also the same effect. We have to store the 65.0 in the float variable, and if we are not doing it, we are not doing the explicit widening, then also we have the same effect. We have to store the 65.0 in the float variable. That's all for this video, guys. Don't forget to like and share this video, subscribe this channel if you are new, and leave your valuable comments in the comment section below. Thanks for watching. See you in the next video.